Okay, so continuing with this calculus review sheet, problem number 13. Find two positive numbers whose product is 120 and whose sum is a minimum. I'm going to say, let's call these numbers x and y, and we know that when we multiply them together, we get 120. And the sum would be x plus y. And this is what we want to minimize. We want to minimize the sum. So basically what we're going to do is follow a similar protocol to what we've done in the last video, where whatever it is you want to maximize or minimize, that's the equation you're going to take the derivative of. So let's work with this to figure out what y is in terms of x. You could have also done vice versa, or we could do vice versa. We could figure out what x is in terms of y, but you just kind of pick one. Y equals 120 over x, so that means we could replace this y with a 120 over x. And that's really 120 times x to the negative 1. So that is the sum. Now, if we want the derivative of the sum, I'm going to use this notation instead. If you want the derivative of the sum, that would be 1 minus 120 x to the negative 2, and that is also known as 1 minus 120 over x squared. Now, in order to finish the process, we do have to set this derivative equal to 0, and in doing so, we would get a situation where we'd have to add 120 over x squared to both sides. I've learned that you could, whenever you have a variable in the denominator that you want to solve for, and the fraction's here by itself, and you have just a single monomial over here, it's actually not a bad idea to just swap this with that one. So in other words, that whole equation could be rewritten as 120 over 1 equals x squared. Now, that means that x equals the positive negative square root of 120, and that would simplify into, well, let's see, 120, 60, 230, 215, 3 and 5. Looks like there's an 8 in there. This would constitute a perfect square. So that would be 2 radical. 2 times 3 is 6. 6 times 5 is 30. So that is x. However, let's see. They said find two positive numbers. So therefore, we could disregard the negative one. And therefore, x equals 2 radical 30. So if that's x, well, it's going to be pretty easy to figure out what y is by using this one, this sort of rearranged equation. And it would be 120 divided by 2, radical 30. 120, y equals 120 divided by 2, radical 30. Well, first of all, that would become a 60, that would become a 1. And furthermore, we would have 60 over radical 30. It's often the case we don't want radicals in the denominator, so we can rationalize the denominator, and as a result, this would become 60 radical 30 over just 30, and then I think everyone would agree that could become a 2, that could become a 1, and therefore we have 2 radical 30. So that's the other number, y. So therefore x equals 2 radical 30 and y equals 2 radical 30. Okay, find two positive integers such that the sum of the first number and 4 times the second, I guess that means is 1000, and the product of the numbers is as large as possible. So we're going to be maximizing the product. So in a way, this is kind of the reverse. One number, we'll call that x, is, or the sum rather, x plus 4 times the second. That's going to be 1000. Okay, pause the video if that's confusing to you, but that's what we're going to have to do there. So that's one number plus 4 times the second equals 1000. And we also want to say that the product of the two numbers is as large as possible. Well, the product is x times y, and I'm just going to call that the product. All right. Now, since it's the product that we are maximizing, we are going to want to take the derivative of this. Now, it's going to be good to figure out what x is in terms of y. I think we would agree it's going to be 1000 minus 4y. Therefore, we could plug that in here. That's going to be, instead of x, I'm going to write 1000 minus 4y. 1000 minus 4y. And that's going to be times y, and that's going to equal the product, right? And then it's going to be 1000y minus 4y squared, and that equals the product. And then we're going to take the derivative of this. We're going to take the derivative of the product because we're trying to maximize the product, right? So I'm going to use like an apostrophe. I know this is kind of weird notation, but we're going to do the prime thing. We're going to say product prime. All right. Different ways of annotating that, I suppose, as long as you know what the heck you're talking about. So we have 1000 minus 8y. And then, of course, we're going to set that equal to 0. That's typically what we do, right? That's going to equal 0. And therefore, we are looking at 8y equals 1000. And therefore, y is definitely 1000 over 8. And that is definitely going to be 500 over 4, aka 250 over 2, aka 125. So yeah, so it turns out 1000 is actually divisible by 8. It is 125. So then you might be wondering, okay, well, what about x? What is x? Well, you could always use the rearranged equation, which is right here, and take it from there. So that's going to be x equals 1000 minus 4 times 125. Well, 4 times 125, I believe, is 500. So that's going to be 500. Boom. So those are the answers. Okay, a 216 meter squared rectangular garden is to be enclosed by a fence and divided into 2 equal parts by another fence parallel to one of the sides. What dimensions for the outer rectangle will require the smallest length of fence? So first, it's going to be good to draw it. Now, it probably looks something like this, I guess. And we know that, if we take this into account, that's the entire length and that's the entire width. I'm going to make that capital, actually. We're going to make that capital. So let me actually erase this. I could already see that might be necessary. So big capital L. And we know that capital L times W is going to be 216 because that's the area of the whole thing. That's what they say. The whole garden is 216 meters squared. So that's really the first equation. You can set up what dimensions for the outer rectangle will require the smallest total length of fence. So we want to know what are the dimensions that would require us to use the least amount of fencing possible. Well, how much fencing are we using? Well, How much are we using? Well, we're using, maybe it doesn't matter that I used the capital. We're using 2 times L, right? 2 of those red pieces. And we're going to be adding 3 of the blue pieces, right? Isn't that what we're doing? So the total amount of fencing we're using is 2 times L. I'll use red for L. And we're going to be adding on top of that 3 times W, right? Let's color code those W's. So that's the total amount of fence being used. So what we want to do is minimize the total length of fence. We want to minimize this. So that means that we're going to take the derivative of that. However, as per usual, let's solve in terms of one of the variables. So if we were to solve for L, it would be 216 divided by W, aka 216 times W to the negative 1, which means that anytime we see an L elsewhere, we could replace it with that. And that is precisely what we're going to do here. It's going to be 2 times that, 216 W to the negative 1 plus 3W, and that equals the fencing. I say we simplify that a bit more. 2 times 216 is 432, W to the negative 1 plus 3W, and that equals the fencing. So let's find the derivative of that by putting a prime over this fencing thing. I know that's unusual, but just bear with me. So we're going to do a little prime there. That's a prime symbol. And then we have a negative 432, W to the negative 2 plus 3. And I think everyone would agree that's going to be negative 432 over W squared plus 3. Then we're going to have to set that equal to 0, so let's just get that over with. If we were to add 432 over W squared to both sides, we would end up with 3 equals 432 W squared. We could then swap these out. You would end up with W squared equals 432 divided by 3. Now 432 is divisible by 3. That would be 144, I believe. Yes, and then we have W squared, so W equals 12. So then if you're curious as to what L would equal, well, that would be found in the rearranged formula right here, and therefore, L equals 216 divided by 12, and that is 18. So that is the answer because they asked for the dimensions. The width would be 12 and the length would be 18. And they also asked how much fence will be needed, and that's given by this equation here, right? So L is 18, so that's going to be 2 times 18, which is 36, plus 3 times W. W is 12, so 3 times 12 is 36. So that's going to become 36 plus 36, which is 72 units. Okay, Norman window has the shape of a rectangle surmounted by a semicircle. Okay, so that would be this. Like that, right? If the perimeter of the window is 30 feet, find the dimensions of the window so that the greatest possible amount of light is admitted. Okay, so that's code for maximize the area. Hopefully that makes sense, because the larger the area of the window, the more light will get through. Okay, so they're being weird with the way that they're wording it. Um, we have this piece, we have this blue piece, we have a red piece that's the same, and we have this yellow piece. Ultimately, we don't need that dotted line. I just kind of wanted to highlight the fact that, hypothetically, we could have drawn a line that would be of equal length to that blue segment there. I think we would agree that the perimeter of this whole thing is going to be a matter of taking the sort of almost rectangle thing and then adding the semicircle length. And we know that the perimeter of this thing, they already told us, it's 30. Now, let's start labeling this stuff. So we're going to call this, I'll call this the height, which makes that the height. Let's call this the base, and let's call this the S for semicircle. Now, the S is going to be half the circumference. So it's going to be 2 pi r divided by 2, aka pi times whatever the heck the radius is. Now, I think we would agree the radius is going to become 1/2 b, right? 1/2 b, because here is the radius. I'll use purple. Anytime there's something weird going on, I'll use purple. So that's the radius, which is 1/2 b. So the radius is right there, which is 1/2 b. So we're going to say that the proper way, perhaps, to label the length of this semicircle is to call it pi times 1/2 b, all right, or b over 2. So I'm going to go ahead and just sort of transfer that insight here, because we just figured out what the sort of length of that yellow semicircle is. It's pi times b over 2. Now the question is, what is the length of the rectangular part? Well, it's 2h plus b, right? It's 2h plus b. And then we're going to be adding that to pi times b over 2, and that would give us 30. So anyway, we've created an equation that represents the perimeter of the entire window. Hopefully that makes sense. Okay. Now, the area of the window is a different story. The area, which I'm just going to write area, which by the way we're trying to maximize, is going to be the rectangle formed by the sort of shape at the bottom. It's going to be this rectangle plus the area, let's keep this red, plus the area of the semicircle, right? So that's the area of the whole thing. Now, what is the area of the rectangle? Well, that would be b times h. That would be b times h. So b times h. And then we're going to be adding plus 1/2 pi r squared, because the area of a whole circle is pi r squared, but we're looking for a half of a circle, so it's going to be 1/2 pi r squared. But let's put that in terms of b, at least that part for now. We have 1/2 pi times b over 2 square. We had already discussed that the radius is b over 2. And I'm going to also suggest that we do something else, and that is to go ahead and just square that now, just to sort of get it over with. That would be b squared over 4, and that could simplify further to be b times h plus b squared over 8 times pi. That is the area formula that I'd want to work with personally. So focusing on these two equations, clearly part of the problem is that we have two variables. We have h and we have b. Now pi is not a variable, pi is just a number. But we do have two variables, h and b, b, right? And we know that we want to take the derivative of this because we're trying to maximize the area, which means we're going to take the derivative of this equation. But we have two variables. So the fact that b is squared means to me that I'd rather leave b alone and just figure out what h is in terms of b. So I'm going to do that over here. We're going to find out what h is in terms of b. And the way that we're going to do that is we're going to subtract these terms from both sides. So it becomes 30 minus b minus, I'm going to do it like this, b over 2 pi. And then I'm going to be dividing everything by 2. So that becomes h equals 15 minus b over 2 minus b over 4 pi. So that's something that we could plug in for h over here, okay? So let's do that now. The area actually equals b times something large, which is 15 minus b over 2 minus b over 4 pi. And we're going to then be adding b squared over 8 pi. We could then distribute the b in the first parentheses. It becomes 15b minus b squared over 2 minus b squared over 4 pi. And then we have plus b squared over 8 pi. Okay, so then I'm going to rewrite this in a way just based off of experience that I know is going to be a little bit easier to take the derivative of, or at least understand the derivative, and that is to do this. All right, if you have pi, you might want to just remember that is a coefficient, that's a number. So this is b squared over 2, but it's really negative 1/2 b squared. The pi could go on top in the numerator, so it's really minus pi over 4b squared, and like that. So I think it's helpful to always have the variable on the right before you do the derivative, otherwise it's going to be confusing. Okay, so at this point, I'm ready to do the derivative. Now let's just remind ourselves, I mean, all we've done is we've taken this area and we've put it in terms of b, essentially, right? We chose a variable, we put it in terms of b, so now we're going to find the area, the derivative of the area. So the area prime, that's going to become 15 minus b minus pi over 2b plus pi over 4b. Pause the video if you're not sure about that. I'm pretty sure that's right, though. Setting that equal to 0. Now to actually find the value of b that corresponds with the maximum area. Well, there's definitely a 15 hanging out. But then there's all these that are essentially, you could say that they're like terms, but probably a better way of managing these three terms right now is to factor out the GCF, which I'm going to call a negative b. So we're going to factor out a negative b, and then it becomes 1 plus pi over 2 minus pi over 4. And at that point, we can add this whole thing to the other side. So I know it's kind of getting messy, but just bear with me. It's going to be b times all this. Now let's think about this right now, actually, before I write it. Hopefully we would understand that 1 is really 4 over 4. Hopefully we would also understand that pi over 2 is really 2 pi over 4. So therefore, we could simplify this with these common denominators, where there certainly would be a 4 underneath. But then up top, it would be 4 plus 2 pi minus pi. Well, 2 pi minus pi is just pi, right? So it would be 4 plus pi up top. So it would be 4 plus pi up top. And that is going to equal 15. So if we want to solve for b, well, it's just going to be b equals 15 divided by this, which is really 15 times the reciprocal of 4 plus pi over 4. And the reciprocal of 4 plus pi over 4 is 4 over 4 plus pi. So that's going to become 60 over 4 plus pi. So that right there, 60 over 4 plus pi is the base. So I'm actually going to write that. 60 over 4 plus pi. So if we have already found the base, what else does that allow us to find? Well, it should certainly allow us to find the height, right? It should certainly allow us to find the height because apparently the height is equal to all this. So that unfortunately is going to be sort of an annoying situation, clearly, where we're going to have to recognize that b equals this and then plug it in there. So let's kind of do that off to the side. That would be 15 minus, I'll use parentheses for now, minus parentheses over 4 times pi. What belongs inside the parentheses? Well, b, and we already discovered b is 60 over 4 plus pi. 60 over 4 plus pi. Anytime you have a denominator over another denominator, you can multiply the two denominators. So that becomes 15 minus 60 over 2 times 4 plus pi. And we're going to be subtracting. By the way, this pi could get multiplied to the top. So that's going to become 60 pi over 4 times 4 plus pi. So then the question is, what does that simplify into? Well, first of all, we could cancel that, turn that into a 30. Cancel that, turn that into a 15. So really what we're dealing with is 15 minus 30 over 4 plus pi minus 15 pi over 4 plus pi. So looking for a common denominator, it looks like 4 plus pi is a good candidate. So let's multiply this by 4 plus pi over 4 plus pi. And as a result, well, we'll definitely have 4 plus pi underneath. But up top, we would have 15 times 4 plus pi, which I'm going to work out soon, minus 30 minus 15 pi. And then that would become 60 plus 15 pi, definitely 4 plus pi underneath, right? 60 plus 15 pi minus 30 minus 15 pi. So these would cancel, and we would have 60 minus 30, which is just 30. So that would become 30 over 4 plus pi. So that is the answer to the rectangular height, 30 over 4 plus pi. So that is 30 over 4 plus pi. With regards to the semicircle, that's going to be pi times b over 2. So I don't mind just doing that right now. That's going to become pi times something over 2. And that something is 60 over 4 plus pi. And as I said before, you can multiply these denominators. And as a result of doing so, you would get pi times 60 over 2 times 4 plus pi. And that would become a 1, that would become a 30. So that would ultimately be 30 pi over 4 plus pi. So that is a little different. It's kind of similar to the height, except it's got a pi in the numerator. So this height is just 30 over 4 plus pi, but this is 30 pi over 4 plus pi. And that actually, when you think about it, kind of makes sense as it relates to pi times r and all that stuff. But anyway, don't worry about that. So this is the semicircle length. So I'm not really sure if the teacher wants his students to include the semicircle length in the quote unquote dimensions. I'm not so sure, but that is the length of the semicircle with no variables, because remember, pi is an actual number, right? So this is the numerical value of the length of the semicircle. This is the numerical value of the height of this rectangular piece, and this is the numerical value of the length of the base. And I do want to just make sure we answered the question, though. Find the dimensions. Okay, yeah, we did it. Okay, problem number 17. Find the antiderivative of that function right there. So this is the first time, at least on this review sheet, where we are being asked to find an antiderivative. And let's set it up. So it would be this. I can already see where this one's going to be going. And where it's going to be going is first to recognize that you could split this denominator. So it's underneath everything. So we would have 4x to the fourth over x squared plus 2 radical x over x squared. And we would have our dx there. Now, at that point, you could clearly turn that into a 2, cancel that one entirely, and also recognize that this is really x to the 1/2. In fact, I'm just going to rewrite it that way. X to the 1/2. So anytime you have the square root of something, it's really secretly an exponent of 1/2. And therefore, this can be simplified as well. So let's kind of analyze x to the 1/2 over x squared. Well, hopefully you remember that you could always keep the base and subtract the exponents. Now in this case, that will be keeping the base of x to the 1/2, or x rather, minus, and 2 is secretly 4 over 2. So that would be x to the negative 3 over 2. So ultimately, this is going to be 2 times, this quotient here. And the quotient we just discovered is x to the negative 3 over 2. Now, I'm going to rewrite it that way, actually. And I think that's going to be helpful for the antiderivative part. So it's x to the negative 3 over 2. So I'm just going to simply replace it with that, x to the negative 3 over 2. And while I'm at it, I'll just save space by just remembering that that's gone, and really it's 4x squared. 4x squared. So we're just going to use the eraser. And good, 4x squared. So now we're ready to apply the power rule to everything. So it would be 4 times x to the third over 3 plus 2x to the, let's see, that would be adding 2 over 2. So that would be negative 1/2 over negative 1/2 plus c. Now that could be confusing because it's like, oh, it's 2x to the negative 1/2 over this thing. Well, anytime you divide by a fraction, it's really the same thing as multiplying by the reciprocal of the fraction. So on the next line, I'll just kind of represent the situation. This would be 4/3 x cubed. And it's definitely going to be minus 4 x to the negative 1/2, which we're going to worry about later, and plus c still. And then at that point, I think we are ready to go ahead and just say that the antiderivative is 4 over 3x cubed minus 4 over the square root of x plus c. Now, I've noticed most professors do not mind if the radical is in the denominator in the final answer of an antiderivative. So this is the answer. Okay, find f if the second derivative of f of x is 20x cubed plus 12x squared plus 4, and then they give us a few clues. So the game plan here is to recognize that, okay, this is the second derivative, so what we have to do is find the antiderivative of this, and then find the antiderivative of the result, and then we would have the original f of x. Then we would have to use these clues to figure out if there's a constant and what that constant is. So with regards to the situation, it would be f double prime of x is equal to 20x cubed plus 12x squared plus 4. Now the antiderivative of that is going to be the first derivative of f of x, okay? And that's going to be the derivative of this whole thing. Now, you don't have to write all of that, okay? I'm kind of writing this weird train of, you know, expressions and so on. You don't have to do it this way, just as long as you know that the big picture game plan is to take the antiderivative twice and then use the clues they give you, as I said before. So this will be a straight up power rule situation. So it's going to be 20 x to the fourth all over 4 plus 12 x to the third all over 3 plus 4x. And then it is plus c. I mean, that's true. And then we could call that 5x to the fourth plus 4x cubed plus 4x plus c. And at that point, we would have to take the derivative of that, or the antiderivative of that, to get to the original f of x. So let's focus on that right now. So once again with the power rule, it would be 5x to the fifth this time over 5 plus 4x to the fourth over 4 plus 4x squared over 2, and then plus cx just in case, and then we could say plus d over there just in case there is a constant. Now that, of course, could simplify where all those cancellations would take place. We would then have x to the fifth plus x to the fourth plus looks like 2x squared plus cx plus a constant d, and that would be f of x. And then we could use the information that they gave us. Apparently, f of 0 is equal to 8, and apparently f of 1 is equal to 5. So if f of 0 is equal to 8, that means that when x is 0, the whole thing is equal to 8. So that means that this d is 8. So I'm going to go ahead and replace d with 8. Now pause the video and think about that if need be. Now they also say that when x is 1, y equals 5, or when x is 1, the function equals 5. So in other words, it should be the case that f of 1, well, certainly equals this, right? Empty parentheses all over the place. Plus c times plus, and then I got rid of that 8 by accident. There should be an 8 there. We'll keep it in red. And that whole thing, this whole thing equals 5, and we would have 1 everywhere here. So let's go further. That would be 1 plus 2 plus c plus 8, and that should equal 5. Well, 1 plus 1 plus 2 is 4, plus 8 is 12. So we have ultimately 12 plus c equals 5, therefore c equals -7. So that is what C equals, and therefore we can know for sure that this original f of x function here is, when you write it as its complete form, f of x equals x to the fifth plus x to the fourth plus 2x squared minus 7x, because c turned out to be negative 7, plus 8. That should satisfy all the conditions.